Hi everybody, we're going to start a short unit on limits. It's just going to be 4 lessons long, and then we'll have a test and that'll be our final grade. I'll also put in a bonus assignment for that short week, the 8th, 9th, and 10th, Monday through Wednesday, for you to do if you'd like to do it. So this last unit is on limits. Limits is a topic that I definitely wanted to squeeze in because you will see it in calculus. So today we're going to talk about limits just by looking at graphs and tables, and then in the coming days we'll talk about different tips and tricks and other ways to find limits. So here I'm just going to start with an example. So given this polynomial x squared minus 3x plus 4, it's a parabola, it's sketched out here. You can also follow along many of these examples in your book. I might not be doing them in order, but they start on page 830 and go up to like age 835, so you can take out your textbook and follow along there. I don't want to go through drawing the graphs by hand or by using my calculator because it'll make the video super long and I don't want to do that. So this is saying find the limit as x approaches 1. So as we get close to the number 1 on the x-axis and get close from the left side and get close from the right side, you gotta look at both angles. We're looking at this parabola over here. It's sketched out. So as x gets close to 1, so as we get close to 1 from both sides, follow it in. What value do we get close to up here? What y value? So if I'm looking at x is 1, you can clearly see we're going down to the number 2, and you could find out that this is the number 2 by looking at your table. And if you look from the right side, you can see we're going up to the number 2. So since you approach the number 1 on the x-axis from both sides and it's getting close to the same number of 2, that is what's called the limit. So the limit is just finding, is there a number that we're getting close to when you look at both sides of this x value, from the left and from the right. So a little bit fancier terminology up here. L, right here L, is the limit of the function as x approaches a. A can be a number, a positive or a negative. So you're just looking at a certain number, and you're getting your look from the left side and the right side of this function, and if they get close to the same number, then that's what the limit is. It does not have to equal the number. In this instance it did, but you'll see some instances where it does not. So let me give you another example. So let's say we had this equation right here. Now if you plug this in your calculator and stop the video real quick, make sure you put parentheses in the numerator and parentheses for the denominator so your calculator can specify between the two. When you graph it, it's probably going to look more like a line. But one thing that's important to note is that the denominator of a fraction cannot equal 0. It's undefined. So if you set this denominator equal to 0 and solve, x minus 2 equals 0, you get x equals 2. So if x were equal to 2, then this function would be undefined. So that results in what we call a hole in the graph. So when x equals 2, there's a hole. And I say that because when you graph this in your calculator, you're probably not going to see it because it's just such a small area where the graph doesn't exist. So you just have to be smarter than the calculator and figure that out. So now looking at this graph here, and then also looking at the table in your graphing calculator, one thing that you can notice, at the limit as the graph, move that up, as x approaches 2 on this graph is 4 because when you look at the x value of 2 and you come at this point of x is 2 from the left and from the right, do you see how when you come from the left and from the right, we're approaching the same value here, which is 1, 2, 3, 4 on the y-axis. So the limit in essence should always be a y value. What y value is the x value approaching? So when you approach the x value from the left or from the right, it gets close to the y value of 4. You can also tell by looking at a table of values, for example, a table that you can create on your own by subbing x values or looking at your graphing calculator. And you can see here, as we get close to 2 from the left side, it approaches 4. When I get close to 2 from the left side, going down to 2, it also gets close to 4. And then that would be the proper way of writing it right here. The limit of this function as x approaches 2 equals 4. So let me find another example now. So this drawing is pretty bad. You probably want to look at your textbook for this one. The limit where this graph, which is a piecewise function, approaches 3. You can also, again, make piecewise functions. We talked about that in a previous unit by just subbing in x values for everything that's less than or equal to 3, subbing in x values here for everything bigger than 3, and making the graph on your own. If you plug these both into your graphing calculator at once, you're going to get both at once. So you don't want to do that. So if I made this piecewise function, just by hand sketching over here, you can see that these are 2 lines, and they actually meet at the point 7 up here. So if you were to graph these 2 lines, they actually intersect at the number 7. But hence, when I look at the x value of 3, that's what we're approaching. When I look at it from the left and from the right, I want to see what y value are we getting close to. So when I look at the number 3 from the left and from the right, it is approaching the y value of 7 from the left. It's approaching the y value of 7 from the right. And since it approaches the same number from the left and the right, we can find its limit, which is 7. So you can also tell by looking at the table on this one over here. This is the table for the first graph, this is the table for the second graph, and you can see that they both have the 0.37. So these 2 graphs intersected at that point. Now let me take a look here at a trig function. This one I will put in the calculator for you just to show you. So we're gonna find the limit of this trig graph as x approaches 0. In this instance, x would have to be in radians, so I'd have to make sure my mode is in radians, which it is, so I'm good. I typed into my y equals sine of x divided by x. And then a little cheat method when you're doing a sine graph, you can always do zoom trig, which is number 7. And that'll give you a graph that's approximately negative 360 to 360. It's just a faster way of getting there instead of going to your window and doing, negative 360 to 360. Now here you see negative 6 and 6. These are radians. And then here's the y min and max. So this question says that x approaches 0. So one thing to note about this is, again, if you have a denominator, remember the denominator can equal 0. So at x equals 0, there is a hole in this graph. And again, you can't see it. Those holes are super small, so you just can't see them. But if I go to the table, I could see at 0, there's an error. Now, it doesn't matter that the graph doesn't exist at 0. We just want to know, as the graph gets close to 0, what number does it approach? And you can kind of tell. It looks like it's getting close to 1 from both sides, but never assume. Always look at your table. And you can see it is. It's going up there. If you were to do something closer between 0 and 1, like, I don't know, 0.5, for example, I can go to second table setting. If I want the graph to start at negative, or I'll do positive 0.5. You see how I'm getting closer to 1? And if I do second table set, I want to get closer to 1, I could do, 0.8. If I go to the table, see how we're getting closer and closer to 1 there? Oops, I did that one backwards. I wanted to go closer to 0, and I went the opposite way. So if I do second table set, not 0.8, maybe like, I don't know, 0.1. Now we're really close to 1. So the limit as x approaches 0, even though it doesn't exist at 0, would be 1, because it's getting close to 1 from the left and from the right. All right, one more like that, and then we'll move on to a different scenario here. So in this graph, again, because I have a denominator, we can't have a denominator equal to 0, so If you take this equation, set equal to 0 and solve, x would be -2. If x is -2, then this entire fraction here would be undefined. So that would result in a hole in the graph. So again, when you graph this, you probably won't see it because it's super small. And it doesn't matter that the graph doesn't exist at -2. That should be -2. We just want to know, as the graph approaches -2, does it get close to the same y value? And it does. So if you look at the -2x value here, when you approach it from the left and from the right, it gets close to the y value of 2. So that's its limit. And again, you can tell that by looking at the table for this graph as well. Again, if you put this in your calculator, make sure you use parentheses for the numerator and the denominator. Now, I've been saying all along is if you approach the x value from the right and left and it gets close to the same number, then that's its limit. But what happens if it doesn't? So there are limits that do not exist, and we write DNE for do not exist. So if there's no single value that is approached by f of x as x approaches a, we say f of x does not have a limit. So let's take a look at an example where that would happen. So here is an example. The graph 1 over x squared. And we're going to approach this graph as x approaches 0. So here's 0. Can you see that if I come in from the left and from the right, both sides, the graph is going up infinitely. So it's not approaching a single number at all. And because it's not approaching a single number from the left and from the right, we say that the graph does not exist. The limit of the graph does not exist. So one more example of how that would work. Take a look at this piecewise function. Let me just get it so you can see the whole screen. There's the f of x equals. So if I want to look at this piecewise function, as x approaches 2, here's 2, can you see that when you come from the left and from the right, they're approaching different numbers? This graph is going up, and this graph is going down to a different value. So because as you get close to the x value of 2 from the left and from the right, because they don't approach the exact same number, we would say that the limit does not exist. And again, you can just write DNE does not exist like that. So next thing would be your homework assignment for this day. Would be page 835 to 837, 7 through 39 odd. Make sure you're checking the odd answers in the back of the book. We'll have one more lesson this week, and then we'll have 2 lessons next week, one on Monday, one on Wednesday. And then I'll post your test right away after that and just give you a couple days to do it. Have a good night.